Hi there. In my last class, we had discussed about right angles and circles. I had also attached two sets of question papers from John sir. For those who are not familiar of how to download the question papers from description box, here's how to do it. Get onto my video link. You can see a small triangle on the right side. Click on that triangle and the description box will drop down. The link will be in the description box. You can click on that link and download the question papers. Today, I'll be posting the answers for those question papers in the description box, and also I'll be posting 3 more question paper sets from today's class. Please download them from the description link. Today's topic is chord, angle and arc. In our last class, we have studied that the angle in a semicircle is a right angle. Well, circles have a lot more interesting facts to tell you. Let's view some of them. So as discussed, we have already understood that the angle in a semicircle is a right angle. All angles in semicircle are right angles. Now what if this arc is more than a semicircle? What about the angles inside an arc that is more than a semicircle? See the picture. You can see that all those angles are clearly less than 90 degrees, isn't it? Next, let us see the same fact in an arc that is less than a semicircle. What about the angles which is less than a semicircle in an arc that is less than a semicircle? See my picture. All the angles are greater than 90 degrees. So what have we just seen? We have just seen that all angles in a semicircle is 90 degrees. All angles in an arc that is greater than a semicircle will be less than 90 degrees, and all angles in an arc that is less than a semicircle will be greater than 90 degrees. Take a look at these beautiful patterns created by the ideas we have just studied. Nice, aren't they? Let us now think more about non-diametrical chords and the arcs made by them. The picture shows such an arc. We already know about central angles in 9th standard. I have drawn the central angle of the arc which is in dotted line. Let us say the central angle C. Central angle is C. Now let me draw an angle in the opposite arc, as you can see. What we need to know is the relation between the central angle and the angle in the opposite arc. I have joined C to the center O, where we get 2 triangles now. We can see 2 smaller triangles. See the first triangle. It is formed by 2 radii and another line. So it's an isosceles triangle. Let us say the 2 equal angles are x and x. Now where is the third angle? Yes, over here. The third angle will be 180 minus 2x, isn't it? The same cases can be seen in the other small triangle. It is also an isosceles triangle. Let's say the equal angles are y and y. And the third angle will be 180 minus 2y. The next thing we have to think about is the angle around a point. See, look at the center of the circle. Which are the angles around the point? The angles are 180 minus 2x, 180 minus 2y, and C. These 3 angles together will be 360 degrees because angles around a point is 360. Look at what I have written. 180 minus 2x plus 180 minus 2y plus c is equal to 360 degrees. From that we deduce that 360 minus 2x minus 2y plus c is equal to 360 degrees. 360 cancel off from both sides and we have minus 2x minus 2y is equal to minus c, taking c that side. In other words, c is equal to 2x plus 2y, or c is equal to 2 times x plus y. What is the meaning of that? If you see angle C in the figure, that angle is x plus y because it is made of x and y. And C is our central angle of the opposite arc. Doesn't that mean that the angle at the center is double the angle at the opposite arc? It also means that x plus y, the angle in the arc, is half the central angle of the opposite arc. What have we just observed? Let's put it in a simpler way. I have drawn the circle and you can see its central angle. By drawing an angle in the opposite arc, we get that the measure of this angle is half c. The same thing applies if the angle made is in a smaller arc. See the next picture. We need to find the relation between the central angle and the angle that is made in the small arc. Now we have to consider the central angle of the alternate arc. The alternate arc is the bigger arc. It's quite big. So its angle will be larger. Central angle will be large. Let us say C is the central angle of the bigger arc. Now the angle in the opposite arc will be half of that central angle. So the angle in this arc is c by 2 or half of c. Thus, we observe that the angle made by any arc of a circle on the alternate arc is half the angle at the center. We can deduce another fact from this also. Circle, central angle. Let me draw an angle in the opposite arc. The measure of that angle will be c by 2. Now let me draw another angle in the alternate arc. The measure of that angle will also be c by 2. Drawing another angle also gives measure c by 2. And so on. All the angles in the arc are equal. Thus, all angles made by an arc on the alternate arc are equal. Here is another interesting fact. The circle that is drawn here has been divided into 2 arcs by 2 points. We can call these arcs alternate arcs, or we can say the arcs are complementary. Let us consider the central angle of any one arc. See, this is the central angle of this arc on this side is c degrees. Making an angle in the alternate arc, it has a measure of half of c degrees. Let the central angle of the complementary arc be d degrees. Then marking an angle in the arc opposite to that arc will have a measure of d by 2. By looking at the center, C and D together makes 360 degrees. Well then half C and half D will be half of 360 degrees. Half C plus half D is equal to 180 degrees. So these two angles, half C and half D, they are supplementary. Thus we can conclude that a pair of angles on an arc and its alternate arc are supplementary. Well, children, I have told you circles have many interesting facts to tell. Let us see what all things we have observed today. We know that the angle in a semicircle is right, and so the angle in an arc which is more than a semicircle will be less than 90 degrees. And the angle in an arc which is less than a semicircle will be greater than 90 degrees. And we have observed that angle made by an arc of a circle on the alternate is half the angle at the center. All angles made by an arc on the alternate arc are equal. And also that a pair of angles on an arc and its alternate arc are supplementary. Now here is an interesting question. Shown here is a clock. The numbers 1, 4 and 8 are joined together to form a triangle. Calculate the angles of this triangle. A clock is circular, isn't it? So it probably has many properties of circles. The 12 numbers on the clock are all 30 degrees apart, because totally in a circle we have 360 degrees. 360 divided by 12 gives you 30 degrees. So each number on the clock is 30 degrees apart. Now consider the number 4 and the number 8. How much are they apart? 4, 5, 6, 7, 8. 4 to 5, 30 degrees, 5 to 6, 30 degrees, 6 to 7, 30 degrees, and 7 to 8, 30 degrees. Totally 4 and 8 are 120 degrees apart. The central angle of 4 to 8 is 120. Now look at the top angle of the triangle. Isn't it in the arc alternate to the 4 and 8 arc? So then we have the result that the angle in an arc is half the central angle of the alternate arc. So that will be half of 120, that is 60 degrees. Similarly, we can see the numbers 1 and 4. From 1 to 4 we have 3 divisions. So 30 into 3 is 90 degrees. The central angle between 1 and 4 is 90 degrees. And so the opposite angle, or the angle in the opposite arc, will be half of 90, that is 45. Now let us consider from 8 to 1. There is a distance of 150 degrees. That will be the central angle over there. And the opposite angle over here will be half of it, 75. Well, we have seen the angles of the triangle. 60 degrees, 45 degrees and 75 degrees. Very interesting, isn't it? Now let's see how we draw a triangle of 30 degrees, 70 degrees and 80 degrees and of circumcircle 2.5 centimeters. This is how our triangle should be. Circle of 2.5 centimeters and the triangle has 30 degrees, 70 degrees and 80 degrees. Think about it. If one of the angles of the triangle is 30 degrees, that angle is an angle in an arc of the circle, isn't it? So then, its central angle will be 60 degrees. Double of 30, that is 60 degrees. We can use this idea and try to draw the triangle. Okay, let's begin our construction. First, I draw a circle of 2.5 centimeters. Now I need a central angle of 60 degrees first. So I draw a radius, keep my protractor ready, measure 60 degrees and mark a point on the circle. That's our 60 degree angle. Let's join the two end points of the angle. Okay. Now surely, since the central angle is 60 degrees, the angle in the opposite arc will be 30 degrees. So we are sure that any angle drawn on this arc will be 30 degrees. Keep that in mind. Now let's think about the second angle. We can take 70 degrees or 80. Let's take 70 degrees. One side of the triangle is drawn by joining the 2 points. Now we need a 70 degrees somewhere on this end or on the other end. Using a protractor, I am going to construct an angle of 70 degrees on one end. Making the angle, it cuts the circle at a point. So that's my 70 degree angle. Now let me join this point and complete the triangle to the first point. Now look, as I told you before, this angle will be 30 degrees because it is half the central angle of 60 degrees. And another angle 70 degrees is constructed. Now surely, if two of the angles are 30 degrees and 70 degrees, the third angle will be 80 degrees. So that's our triangle. The circle is of radius 2.5 centimeters and the triangle has angles 30 degrees, 70 degrees and 80 degrees. Let us see another question which needs proof. O is the center of the circle and A, B and C are 3 points on the circle. Joining A to B, B to C and C to A makes a triangle, and also join O to A. We have to prove that angle OAC plus angle ABC equals 90 degrees. We need to prove this question using the facts that we have studied about circles. Let us think about it. Look at the picture. Let's join O to C. Now OC and OA are both radius. And OAC is an isosceles triangle. So then it has two equal angles. Let's mark them as X and X. We know that the sum of angles of a triangle is 180 degrees. Now in this triangle, the two angles are X and X. So its third angle will be 180 minus 2x. Let us now come to the angle B, also known as angle ABC. Angle ABC is an angle in an arc. According to what we have learnt, the measure of angle ABC will be half the measure of the central angle of the opposite arc. And that central angle is what we have just seen. 180 minus 2x. 180 minus 2x is the central angle of the arc opposite to the angle ABC. So that means angle ABC will have half the measure of the central angle. What is half of 180 minus 2x? 90 minus x. Yes, 90 minus x. So the measure of angle ABC is 90 minus x. Now let's come to what we have to prove in this question. We have to prove that angle OAC plus angle ABC equals 90 degrees. What is the measure of angle OAC? It's x. And what is the measure of angle ABC? It's 90 minus x. Let's add them together. Angle OAC plus angle ABC equals x plus 90 minus x. That means x and x can be cancelled off. Equal to 90 degrees. Thus we have proved that angle OAC plus angle ABC is equal to 90 degrees. Now children, why don't you try to solve some of the problems in your textbook based on this part. We have now come to the end of our class today. A reminder that we have 3 sets of question paper along with this video. You can download them from the description box. The question papers are by the eminent John sir. Thank you and bye-bye. See you next time.